So now this theory works for resistors, for as many resistors as we can put in line. I can put a dot, dot, dot. So we can have R1, R2, Rn, where RT would now equal to R1 plus R2 plus, it could be R3 plus R4 plus dot, dot, dot plus Rn, however many resistors you have. So N just represents, well, if I have 10 resistors, there's going to be 10 resistors in series, and this is how I can calculate the resistance. This is coming from the conservation of energy. This is very beautiful, okay? Now, another thing that we want to look at is the geometrical representation. So RT is equal to R1 plus R2. Let's just take those two. And if everything is equal about those resistors, then we have rho L1 over A. In other words, the area doesn't change, plus L2 over, you know what? I'm just going to say A plus rho times L over A. If A doesn't change and rho doesn't change because we put them in series like this, the only thing that changes when you put them back to back will be their lengths. So you end up with rho times 2L over A. So if we go back to the original page here, oh, I'm doing that wrong. If we go back to the original page here, remember we have L here representing the length. So we're basically putting these two cylinders back to back, just so you guys can see exactly what I'm talking about. We have one cylinder here, one resistor here. We tie them together. We can solder them together. We can also connect them together like so. That's essentially what we have. All right. Now let's consider when we have resistors in parallel. Delta V, you have R1, and then we have R2 here. We know that we're going to have some current associated with this, and we're going to have some voltage associated with this one. We're going to have some current associated with this one and some voltage associated with that one. So our current is coming around like so. In this particular equation, in this particular scenario, we actually have to think about things a little bit differently. The first thing is this. Voltage for each one of these are going to be the same. So what we're saying is this: delta V is equal to V1 is equal to V2. All right. And we're going to again use our power considerations. P power being produced by the battery is equal to power being consumed by resistor 1 plus the power being consumed by resistor 2. We're going to again use our power equation. We can write I times, I'm just going to put delta V here. Equals to I1 times V1 plus I2 times V2.